Hello there. This video is about the similarity of flowcharts for showing that triangles are similar. The last video we saw that there were 3 shortcuts for showing that triangles are similar. I'm going to make a little note of them here. They are angle-angle similarity, meaning we have to have 2 pairs of angles in the triangles that are the same. We've got side-side-side similarity, meaning we have 3 pairs of sides that give the same ratio. Or side angle side similarity, and that's 2 pairs of sides giving the same ratio with the angle between those 2 sides in each triangle being the same. So those are our 3 choices, and there's just like if you were in court making an argument, you'd have to provide evidence and you'd have to be organized in the way you presented it. We do the same thing in math when we make arguments about different shapes. We have to kind of present and organize the information that we have and that we can figure out in a way that's readable and organized, so that we know what is being said. And one way to organize that information is in a flowchart. And a flowchart is a way that we're going to use to show that triangles are similar. So if we're going to show that these 2 triangles are similar, we need to pick which one of these we think we're going to use. Angle-angle, side-side-side, or side-angle-side similarity. Now there's always clues to which one you use here. One clue is that we don't know anything about the lengths of any of these sides. The only things we know are their names, which we always know, and we know that these 2 are parallel. But that doesn't tell us anything about their lengths. So we're probably not going to use side-side-side because we need side lengths to check ratios. And we're probably not going to use side-angle-side because we also need side lengths to check ratios for that one as well. So we're probably going to use angle-angle. So let's start our flowchart with our plan here. And our plan is going to be to use angle-angle. Now for angle-angle, we need 2 pairs of angles that are the same. Now notice here, we're not told that any of the angles are the same. So if we're going to use angle-angle, there's got to be something that we can figure out here. And we do know that these lines are parallel, and angle D and angle W are alternate interior angles. And we know that if lines are parallel, then alternate interior angles are the same. So that's one pair of angles that we can say are the same. So let's say that the measure of angle D equals the measure of angle W. And it's a flowchart, so we put a little circle around it so that we know that's kind of one piece of information. So there's one pair of angles that are the same. Now, O and C are also alternate interior angles. So I could say for the other pair, I could say that these 2 are the same. These 2 are vertical. So I could say those 2 as well. That's the one I'm going to say here. But in this problem, it really doesn't matter. You do have to pick 2 of them, though. You don't need to do 3 pairs of angles. We only need to do 2. So this angle, let's see, that angle we're going to call angle OGD. OGD equals the measure of angle. Measure of angle, we'll call this one CGW. CGW. And we'll put a circle around it. Now we've already shown that we've got 2 pairs of angles that are the same. And we know from the last video that means the triangles are similar. So the next thing we need to do is to say that the triangles are similar. So this triangle right here, let's call it DOG. It doesn't really matter what we call it. Triangle DOG. That symbol right there means similar, or is similar to. It is one little squiggle. 2 squiggles means approximately equal sign is 2 straight lines. This is one little squiggly one. That means is similar to. Okay, now once you pick an order for the points, you've got to be consistent with that order. Now I started with D, so you got to go back over here and say which angle in this triangle here corresponds to D. Well, D and W were the same, so that means since I started with D here, I got to start with W there. Next I had O, and O is the unmarked one. C is the unmarked one here, so those go together. So O is second, that means C is second. And G in this triangle goes with G in this triangle, so G is last. Put an arrow around it. Now we used these two statements to draw this conclusion. So when that happens, we put arrows in our flowcharts like that, meaning we use this information to draw that conclusion. And this one right here, we actually have to justify. And our justification is kind of what we did last time. It's this angle-angle similarity. And so we just put that down here, kind of below and to the right of the oval. And that is just, again, justification for this last statement. And there is our complete flowchart showing that these two triangles are similar. Let's go and look at another one. So here's two more triangles. Now, let's see. All we know about these two triangles are their sides. We don't know anything about the angles. So we're probably not going to be able to use angle-angle. And we're not going to be able to use side-angle-side either because we don't know anything about the angles. We do know something about all three sides of both triangles. That's a clue that side-side-side is going to be the way to go. So our plan here is going to be side, side, side. So anytime we see an S, that means that we've got to have a side ratio to check. Okay, so let's pick one here. Let's say we pick 4. Now 4 is the smallest one here. 4.8 is the smallest one in this triangle. That means they go together. So we make a ratio out of it, or a fraction. And you can put that in your calculator if you want. 4.8 divided by 4 is 1.2. And there is one of our side ratios that we've checked, so we'll put an oval around it. Let's take another side, 5, or let's do 6. Let's do the biggest one. 6 is the biggest one in this triangle. The biggest side in this triangle is 7.2. So we'll go 7.2 over 6. And you can use your calculator, divide those, you get 1.2. Notice they are the same. If they were different, we could stop right now and write not similar, and we'd be done. Flowcharts are only used for showing that triangles are similar, not that they're not similar. If you get two different ratios here, you can immediately stop and say they're not similar, problem done. Okay. 5 is the one we haven't used here. 6 is the one we haven't used here. I've been doing big over small. Make sure if you start out big over small that you do big over small for all of them. If you start doing small over big and big over small in the same problem, you're going to get all out of whack because the ratios will be different every time. Let's see, so 6 over 5, big over small. Use your calculator, divide those, you get 1.2. And all three of those ratios are the same. That is what we're looking for with side, side, side. So we've done all three, checked all 3 pairs. We knew that we had 3 pairs because side, 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 there's 3 S's. So now we're ready to say that the triangles are similar. So let's call this triangle, let's call it XYZ. Is similar to, not equals, not approximately equal to, just one squiggle. Now I started with X. Now that's between the biggest and the second biggest side. It's also the smallest angle. If they're drawn to scale, you can do it that way too. Here's the biggest side, here's the second biggest side. So X is going to go with C. So I started with X, so I got to start with C here. Let's see, I went with Y next. Y is between the biggest and the smallest side. Here are the biggest and the smallest sides, so Y goes with B. And the only one left is A. So there is our similarity statement. We'll put an oval around it. Now we used each of these 3 statements to draw that conclusion. So we'll draw some arrows. And then we got to justify this statement, which is kind of the same as our plan. But side, side, side similarity is how we know that these triangles are similar. Hope that makes sense. If not, get some help in class. Bye.